I really like the exponent laws. I think they're really interesting, and they make sense even though they're really weird. I'm going to show you an exponent law. I'm going to show you the answer to a couple of them. I'm going to tell you that 2 cubed times by 2 to the 5 is equal to 2 to the 8. And I'm going to tell you that 3 squared times 3 cubed is equal to 3 to the 5. And I'm going to tell you that 7 times 7 to the 8 is equal to 7 to the 9. Do you see a pattern happening? What do you think if I did 4 cubed times 4 to the 4? What do you think the answer would be? You see a pattern. What do you think the answer to that last one is? Look at the first 3. See if you see something that gives you a hint. What do you think it's going to be?
Like 4 and 6.
Yes! So first of all, you guys, some of you, at least one, noticed a pattern. Do the rest of you see a pattern that's happening? How did she get the 7?
We add
You just added the exponents? How does that work in this one? When there's no exponent written, there's like a hidden 1 there, because you have 1, 7. Does it work for that one? Yes. Why does it work?
because 7 times 1.
Yeah, that's 7, 1. But why does the rule work? Why is 3 and 5, why do we add them? Because I'm multiplying. This is a little multiplication symbol here. This is what I said. Exponent laws are kind of weird because when you multiply powers, you add the exponents. Why does it work?
Because if you were to do it like 2 times 3 times 2 times 2, and we would add it, it would be like.
This is 2 times 2 times 2. And this one is 2 times 2 times 2 times. How many 2's do you have all multiplied together then?
I said
3 green ones, 5 blue ones, 8 in total. Does that make sense? Like here, if I do 3 squared would be 3 times 3. 3 cubed would be 3 times 3 times 3. Does it make sense that I have 5 3's all multiplied together, that I get 3 to the 5? If you ever, like, we take this exponent rule and we go crazy with it in math, all the way through. Like, we go, like later on in math, they put fractions as exponents. And they could do stuff like this. Any guesses? What this is equal to? 2 to the half times 2 to the half?
3.
No.
4. 2 sobre 2.
It's the same rule. What did you do here with the rule? You added, right? 3 plus 5 is 8. What if you added here? 1/2 plus
2
1/2?
sobre 4.
1.
This is the answer. The answer is just 2. And it works with fractions. And it works with, we're going to do it with variables and a whole bunch of stuff. Yes?
You can use the book for that.
Okay. Thank you. Did you forget yours? Or were you not here when we got this one? Okay.
Answer.
Mm-hmm.
No debería ser un punto porque se multiplica y se están sumando.
Yeah, even though we're multiplying, we're adding the exponents because this is the reason why. If we think about what the meaning of an exponent is, right? When I do this 4 cubed to the 4 to the 4, this 4 cubed means 4 times 4 times 4. This 4 to the 4 means 4 times 4 times 4 times 4. Do I not have 7 4's all multiplied together? So some people remember and memorize an exponent rule. They remember the exponent rule, and there's about 7 or 8 exponent rules in the end. So sometimes I say it's a little dangerous if you just memorize it, because you'll get them mixed up later, like fraction rules. But if we know why they work, and this one is the easiest one to see why it works, then it makes sense when you write it in expanded form, it would make sense that if you had 3 here and 5 there, you would get 8 in total. And this is our first exponent law, called the product law. So again, I'm going to show this in 2 different colors. Write the following in expanded form. And here's the big black dot in between. And we start to use a dot in between for multiplication because we're going to be doing work with algebra with x's, so we can't use x's anymore. And the asterisk just takes too long, so just a dot is quick. This one, if I color code this, 3 cubed would be 3 times 3 times 3.
Wait, why did you change the color? Why did you change the color? Like,
Because I want to show that 2 things multiplied. The first one I'm doing, like I did this one in blue and this one in green. Same thing here, I'm doing this one in blue and this one in green. And the reason I'm doing that is so that, let me write all these 3's. By changing the color, we can see the 2 parts separately. But then when we think about what repeat multiplication is, does it make sense that this one's going to equal 5 to the 8? And does it make sense that this one's going to equal 3 to the, how many do I have?
It's actually 5 to the 7. The first one.
Thank you. I counted them wrong. 1, 2, 3, 4, 5, 6, 7. Thank you. And how many 3's are there? 10? Did I count those ones right? Good. Whew. Yeah, if my counting's not good, I don't think I should come to school tomorrow.
We don't have to.
This is called the product law. The product law says when you multiply 2 powers with, and this is very important, they have to have the same base. You add the exponents and keep the base the same. The rule makes sense if you think about what an exponent means. But sometimes when you go to just do the rule on your own, you might be tempted to do some wrong mistakes. Here are some examples of students that have done wrong mistakes. Don't write these down. These are all wrong. I'll do them in red. I've seen students do this. What did they do wrong?
They added the numbers.
But you're supposed to add the numbers.
No,
They put the
bigger
4.
number.
They put those 2 together, right?
Yeah.
Sometimes you're going to be tempted to multiply those ones. This is wrong. Or I've seen this. What did the student do here?
Added wrong, it should be 7 instead of
It should be a 7 instead of a 10. But they were thinking multiplying, right? Because you're multiplying. And then they saw the 2 and the 5, and what did they do? They multiplied them instead of added them. This is wrong. Anytime you're trying to figure something out, if you're like, ooh, do I remember the rule or did I forget it? Think about what it means. 3 squared means 3 times 3. No. 3 to the 5 means 3 times, oops, I want to go green. 3 times 3 times 3 times 3 times 3. How many 3's do we have all multiplied together? 7. This is your exponent law called the product law. And now we have a bunch of questions for practice. What I want you to do, you can add this in. I don't know if I've included that in your notes or not. Did I? No, I want you to write that in as well. And we're going to do the first two together. And then I'm going to get you to do 1, 2, 3, 4, 5, 6, 7, 8 more of them. And then we'll do the last two together.
Question. Will we go over all of them and correct?
Yeah, I'll give you all the answers. But I want you to try them on your own. So, here, 3 to the 4 times 3 to the 5. The answer will be 3 to the 9. If you imagine it in the expanded form, you'll see the answer. I'm happy if you memorize the rule, but I'm going to tell you that if you just memorize the rule without thinking about it, your chances of forgetting it and screwing it up go way up. If you think about what power means, the rule will be easy. If you expanded this and wrote it all out, how many x's would there be?
Like 12.
Well, there's 12 already here. There's going to be 15 of them. So if you imagine it expanded, you'll be able to answer it. Okay, so I want you to do the rest of these, except for the bottom two we're going to do together. No, you can do them all. Yeah, try them all. I'll pause the video and I'll put up the answers in a bit. We're going to go over these, see how you did. Did you get 6 to the 7? Did you get 4 to the 12?
Wait, I got 11.
Well, there would be 11 here. With these two, there's 11, and then there's one more, makes 12.
Wait, how?
How on that one? Like if I write the 4 squared in green, there's the 4 squared, and I write the 4 to the 9 in blue.
That would be like 11. Yeah.
And then I write the 4 all by itself in purple. How many 4s are there? 1,
6
2,
or 7.
plus 9, 11, plus 1 more, 12.
But how is the exponent 4?
The 4 that happens, when it's not written, you can imagine a 1 there.
So we don't add, we remove. Okay, so add it.
All right. This one is not multiplying. So the best you can do for this is say this is 8 plus 4. And the best you can do is 12, which is technically 12 to the 1.
Wait, so what would it be?
All you could write for that one is 12.
It's 12?
Yeah, so
Why?
math rules are very specific that things have to happen for the rule to work. And the product rule says it only works if you're multiplying. What? This one's a little tricky. Because
Wouldn't it just be like...
that's what the first one means.
Wouldn't it just be 5?
And that's what the second one means. Notice that the exponent is only on the 5 and not on the negative.
Wouldn't it be like minus
There.
5 over
And then a negative times a negative.
positive?
So the answer to this one is 5
10.
to the 10. So again, sometimes when we're wondering, how do I do it in this situation? The best strategy is to go back to your exponent rule and write it out. And here we're going to have 2 to the 8. This one, the bases are different. So the best you can do is say this is 9. And this is 32. What's 9 times 32? 288?
Yeah.
Question.
How do you get 8 on E?
On E?
Yeah.
Because 2 cubed means 2 times 2 times 2. What's 2 times 2?
10.
To 4?
And then what's 4 times 2?
10.
6.
Oh, that's 4 plus 2.
Huh?
Well, 4 times 2.
Oh, 8.
8, that's how I got 8. Because 2 times 2 is 4, and then you have to times by 2 again, you get 8. See how you were tempted to do 6, right?
Yeah.
Yeah.
Wait, so, I don't know.
Okay, look at it again. 2 times 2, 4, times 2 again, 4 times 2, 8. Because you're multiplying all the way through. How many 3's will there be?
7.
Did you get 15?
Yep.
Nice. This, you could do 6 2's. Minus this, you could do 8 3's. But if we wanted a single number, we'd have to type that one into our calculator. So this one is with the decimals or calculator. Yeah. So you type this into your calculator or into decimals, and you find the max. This is good, and then this, it doesn't factor anymore. So you are done when you say this is equal to this. Hold on, that should be x squared plus 7x squared. Okay. If we type that into our calculator, what do we get? 2 to the 6 minus 3 to the 8.
7. How would it be minus 6.9?
6,497. Just type it into your calculator.
Can you explain this, Jake?
For sure. Brandon, your spot's here. People are asking questions, and it's getting way too loud back there. You have to come back to your spot. Okay? Thank you. All right, so question was what?
Can you explain, Jake?
Jake. So these two here, I could use the rule to get this one. Does that make sense?
Yeah.
And these two here, I could use the rule to get that one.
Okay.
But we don't have a rule for subtracting yet, so I just typed the rest into my calculator to get the answer.
La respuesta es 5,120.
Go for this one? Okay. Here, I could do the rule and say this is 4 to the 6 plus 4 to the 5.
Es igual a 11, a 4
What are you doing this morning, my
And this we need in our 5,000. And this one you can't do anything with. It's super frustrating because this means that and that means that none of them are the same letters. We can't put them together. The best you can do is just leave that one the way that it was. It is done. There are some interesting things that happen with exponents, though. Okay? Check this one out. 3 to the 5 means, I like to use blue first. 3 to the 5 means 3 times 3 times 3 times 3 times 3. And 2 to the 5 means 2 times 2 times 2 times 2 times 2. I'm going to test something with you guys to see if you are paying attention. I'm going to first give you a hard multiplication. Do you know that 11 times 13 is 143? 11 times 13, 143. Does anybody know 13 times 11?
140.
Okay, I'll give you another hard one. 29 times 31 is 899. Does anyone know 31 times 29?
831.
899.
Oh, wait,
So-
79.
You guys know already that if you change the order when you multiply things, it doesn't change what it's equal to, right? So 3 to the 5 times 2 to the 5, check this out. That would be 3 times 3 times 3 times 3 times 3.
It would be the same.
And 2 times 2 times 2 times 2 times 2. I'm going to rearrange these. How many threes do I have?
Like 6 or 7.
I have 5, right? I have 5 threes. How many 2s do I have? 5 2s. If I put them in a different order, does it change the answer? No. What's in each of the black brackets?
A 3 and a 2.
A 3 and a 2, which makes?
Wait,
Don't
two
say
times-
5. Don't say 5.
6.
6, good. It makes 6, and this is equal to 6 to the 5.
Wait, can you explain it like
Okay? So I used my 3 to the 5, that's in blue. 5 threes all multiplied together. 2 to the 5, that's in green. 5 twos all multiplied together. If multiplying doesn't matter the order, I rearrange them so I put every 3 with 1 2. 1 3 1 2 1 3 1 2 1 3 1 2 1 3 1 2 1 3 1 2. And each of those 3s and 2s would be, each of this would be 6 times 6 times 6 times 6 times 6.
So we would put 6 and that would be like 5 6s.
5 6s, which would be 6 to the 5.
Okay, I kinda get it.
Check this next one out. I'll do blue first. If 4 cubed means 4 times 4 times 4. And 2 cubed means 2 times 2 times 2. Can you see that if you grouped the 4s, each with a 2,
It would be like 8 or
it would equal 8 to the 3.
yeah.
That's kind of cool. So again, if you're wondering if you're allowed to do something, write it in expanded form and see what comes up. The next rule is the quotient rule. I'm going to show you, but instead of doing, often we write dividing with a line like this. 8 to the 7 divided by 8 to the 5. We write 8 to the 7 divided by 8 to the 5 as a fraction. And the answer to this one is 8 squared. If I did 6 to the 10 divided by 6 cubed, my answer is 6 to the 7. And if I did, I don't know, I did 6 to the 7 again. Right? What are the chances? And if I did 5 to the 12 over 5 to the 4, I would get 5 to the 8.
Wait, how do you get how do you get
You can't even say it, can you?
Savannah Keem, Riley Drake Brockman, and Mackenzie Campbell to the office, please.
how do you get the first green?
O sea,
Divide
una
it.
pregunta.
Anybody think they know the answer to this one?
Answer. Tengo una pregunta. ¿Y por qué no puede ser el número de minis de restar en vez del DVD? Porque está cogiendo el lugar de ya saben.
So look for a pattern. Anybody think they have a guess for this one?
Yeah.
3.
Oh, we subtract.
We subtract.
Exponent.
So when we multiply powers, we add the exponents. When we divide powers, we subtract the exponent. And it's really easy to see if you write it in expanded form. So, 4 to the 9. I'll do this one right here. 4 to the 9 is 4 times 4 times 4 times 4 times 4 times 4 times 4, 4 times 4. And 4 to the 6, I'll do in green, is 4 times 4 times 4 times 4 times 4 times 4. My 4s start to look like y's, don't they? It's a little scary. Okay. Igor, what's 4 divided by 4?
1.
1. So what I like to do here is I go, those cancel out and become 1s. What happens to these 4s?
4 times 4.
They all cancel out and become 1s. How many 4s am I left with?
3.
I'm left with 3 of them.
But when it's like also like sometimes.
Well, they all canceled out on the bottom. And so then you're just left with, because 4 divided by 4 is 1. So when I cancel them out, technically I should write 1 and 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 1. And then you have 1 times 1 times 1 times 1 times 1 times 1. That still is 1. And you're just left with 4 cubed in the end. This is our quotient rule. What do you think this one's going to equal? The bases have to be the same. It's going to equal 2 to the 4. Because if I wrote it out, 2 times 2 times 2 times 2 times 2 times 2 times 2, and 2 times 2 times 2, those would all cancel out, and you'd just be left with 2 to the 4th. What's this one going to equal? How many 3s would you be left with? 4. What if I canceled out more on the, if I had more on the bottom? You see that would cancel out, all the 3s on the top would cancel out, leaving you with just 1. How many 3s would be left on the bottom? 3 left on the bottom. This is called our quotient rule. If you are dividing powers with the same base, so again, highlighting some stuff, the same base is important. Subtract the exponents, keep the base the same. And visualizing it, you visualize that every time you have a number on the top and a number on the bottom, they would cancel each other out. Do you need your one? Okay. I'll do the first one with you, and then you have the next 7 to do on your own. I'll put up the answers in a bit. Four to the 5. I'll pause the video.
When is this going to be?
C is 2. And D here, if you subtract, you would get 6 minus a negative 4, which
No.
is 3 to the 10.
Oh.
What?
Wait, that makes more
How?
sense.
How?
Because it's 2 negative
Because
equal.
if you are
2 negatives.
dividing,
Yeah.
you subtract the exponent.
Thank you.
So I did 6, subtract, and the other exponent was minus 4.
We actually gotta
Subtracting
take
a
the
negative
differentiation.
is like adding.
I have a 57.
6 plus 4 is 10.
Do they get new marks in 82? So I'm not finished my 50. No, like if I handed in one
In E.
last lap I get.
Aquí dos.
I already handed in
X
one thing. Remember
squared.
she wasn't here. We were supposed to do that thing.
Yeah.
I
F,
haven't
you
had
cannot do,
If I
the
had
bases
get
are different.
Actually.
The best you can do is type it into your
An 84
calculator.
probably.
14 y sobre con un módulo.
and tabs.
So if you can't, this next one I think is easiest if you actually write it in expanded form first. The top is A times B times B and the bottom is A times B. Cancel those out.
So it'd be B and then 2.
Feel free to make sound effects while you're doing this. It's perfectly. And the answer is going to be, what are you left with in the end? Just B.
Answer es A, B y un 3.
A's cancel.
I'm so tired.
B's cancel. We're just left with
I'm going to bed right now.
B is the answer.
Esa es la respuesta.
Last night. Same.
10 divided by 5 is 2. How many x's are we left with?
2.
There's 10 on the top, 5 on the
Five.
bottom.
5.
5 are going to be left after you cancel them out.
I want
All right, I have a paper for you to hand in by the end of class.
Answer está una pregunta.
I'll stop the video here.